Swayam Prabha. Digital India. Educated India.
Hello everyone, good evening. So let us start today's session. Yes, so today we are going to actually start with the session 1 on deep dive into Kubernetes, which will help us to understand how do we deploy, right, various AI based services on a cluster. So the agenda for today would basically be the need for Kubernetes. What is Kubernetes? We will have demos, and we will have a demo for load balancing. So the idea here is to link this session with the previous session which Bharat took, who talked about scheduling and orchestration, and he gave a brief overview of what Kubernetes is. In the sense, he showed what Kubernetes is, but he discussed about Scrum, scheduling, and all of this, right? So you now understand the context of why a scheduling mechanism is needed when you use a shared hardware cluster, because there would be so many people trying to use that cluster. You need to ensure that everybody gets, okay, some time on that common scheduled hardware. That is why you use a scheduler, right? So this is the basic concept. Now let us start with today's agenda, and today's agenda is these three. Let us start with a very basic premise of what is the need for Kubernetes. We saw how traditionally people used to use the hardware, okay, and then it basically came up to a virtualized deployment, and then it came to a status wherein we are talking of container deployments, right? And you understand that what a container is by now. And then you also know that since this container deployment needs to be done on a centralized hardware, and there would be people using lot of such containers, there has to be actually a mechanism by which these containers need to be managed, okay, somehow, right? Whether a person is managing it, or there is an automated Kubernetes software which does it, or there are certain other scheduling and orchestrating softwares, right? But somebody needs to manage it, okay? So if you see that way, containers are a good way to bundle the applications, because you have all your libraries, your applications, the dependencies, everything in this container. As we saw in the previous sessions, if this is of a team A, this container belongs to team A, and this container belongs to team B, each might be running different applications with different binaries and different libraries, but it's going to run on basically a common hardware, right? So containers by that mechanism are a good way to bundle applications. Now you need to manage the containers that run these applications and ensure that there is no downtime. Now the concept is this: you have got a very high performance cluster. It has to work 24/7, 365 days, and it need not have a downtime. Downtime in the sense, when you give some service to the client, right, or to a researcher, he would have put in his container and it would be running for, let us say, 2 days, and it has to finish in another 15 to 20 minutes. But assume the situation wherein some particular thing happens or something crashes, and his work of execution of that container for 2 days is lost, right? So how do you manage such things, right? Such issues. So this is where you should understand that if a container by chance goes down, okay, you have to ensure that similar type of container or that container needs to again restart, right? So the question here, what we should be asking ourselves is, won't it be very easier and useful, correct, if this behavior of downtime is handled by some system for us instead of a person monitoring it, doing things, right? Won't it be very helpful and useful if this particular thing, okay, of ensuring that our applications always run on the hardware, okay, even if the node goes down or something happens, we have redundancies into it, the system. So how is that it's managed, right? If we can ensure that, okay, that would be very useful. And that is where this Kubernetes comes into play. Now Kubernetes is a framework to run distributed system resiliently. So we are trying to now come up with a system which ensures, right, that this type of a distributed system which has got lot of compute elements, GPUs, CPUs, memory, everything like this is going to run resiliently, right? Even though you have got redundant nodes, redundant compute stuff, and everything like that, okay, it helps us to run the system, okay, without any faults. It takes care of scaling and failure of our applications, and it will provide deployment patterns. So this is a very, very high level view of what a Kubernetes does. But when you talk of very, very specific things, let us go into a bit of a very, very specific things, which will help us to understand the importance of Kubernetes. Okay. The first thing is service discovery and load balancing. Let us try to understand what does it mean. Okay. So this service discovery, for that matter, is something like my Kubernetes is in a position, right, to actually understand or expose a container using either a DNS or its own IP address. And then it can rediscover all the services available based on the DNS name or the IP address. And if the traffic to the container, in the sense the container would be using certain services, okay, or data, or it has to send data, or if that is the case, if the traffic to the container is high, Kubernetes is going to help us balance that load, right? So it will help us in load balancing, and it will help us in actually distributing the network traffic so that the deployment is stable. Now this basically means that from the network's point of view, you are trying to load balance your traffic. So you have got, let us say, 5 nodes, okay, and everybody wants to get node 1 because everybody knows node 1, right? So everybody gives that to node 1, and what effectively happens is node 2, node 3, node 4 are all free. If that thing load balances, then your total workload is split across various nodes instead of just trying to run it on node 1. So that is how the first thing of service discovery and load balancing is going to actually be served by Kubernetes. The next thing is storage orchestration. So what does storage orchestration essentially means? See, when you try to work with Kubernetes in the days to come, you will see that you are going to work with, let us say, lot of deep learning algorithms, right? So deep learning algorithms, when you have a container, that container will have all the things, but you will have to have a storage from where, right? You can pump in your data to that particular type of a model. You'll be working with huge amount of data because you are working with deep learning applications, and each of these deep learning applications require lot of data for training, right? So if the data is not sufficient, you do data augmentation, you create a lot of data on your own, and then try to use it for deep learning applications. So in such a scenario, Kubernetes also allows you to automatically mount, right, and link the storage system of whatever choice you have. Let us say you will have local storage, you have storages from the cloud, you have got storages from your own laptops or whatever, right? So these type of systems, what to say, storages, right, also could be mounted. Okay, that becomes one of the important features of Kubernetes, that it helps you to orchestrate storage also. Now, when you talk of automated rollouts and rollbacks, very, very important thing, ensuring consistency, okay, across caches, across all the nodes, all of this needs to be taken care of. And Kubernetes does automated rollouts and rollbacks. So we can also have, let us say, a situation wherein we can describe a specific desired state, okay, for our container using Kubernetes. Okay, as you go along, you'll understand how do we do it, but for the time being, just understand that there is a desired state, right, and you have deployed a container. We will see what a deployment means in the demo today, but we have deployed a container, and that actually can be described to the Kubernetes, and this Kubernetes can change the actual state to a desired state, okay, in some fixed amount of time, or maybe some control mechanism using some methodologies. It can actually help us do that, attain a desired state. So we can automate also the Kubernetes to create new containers for our own deployment. So we will show how do we create a container for deployment, okay, on a node, okay, and we can remove automatically existing containers, remove the dead containers, remove certain containers which are having some errors or something like that, and all those resources which are used by, which were used rather by those containers, would again be actually given to these new containers. So that particularly means that you are able to actually get back the resources which were being used by old containers which are not being used, okay, or which are having certain issues, and those resources which are used by them are automatically given back to the system in general. Now, another important point is automatic bin packing. So let us say that since we are trying to use Kubernetes on a cluster of nodes, right, and we know that this cluster of nodes is going to actually run containerized tasks, and we tell now the Kubernetes that how much CPU and memory, okay, each container is going to need. We can allocate that also. So I tell that, okay, this particular container, this particular user will actually require these many CPUs, and this is the memory which would be required by his or her container. So my Kubernetes is going to fit or allocate my container to those nodes which are actually going to make best use of the resources, right? So we will ensure that resources are used very, very efficiently. Now, another important point is self-healing. So what does it mean, right? Self-healing basically means that my Kubernetes installation or my Kubernetes setup is going to restart, okay, the containers that actually would have failed. We can replace the containers, we can kill the containers based on certain criteria, right? So we will see what are those criteria. Those are called as user defined health check things, right? And once the containers is running, and if you are providing some services through those containers to various clients or users, if we define certain health check and ensure that if they are not satisfied, then we are not going to advertise them to the other clients until they are ready to serve. So you indirectly in turn ensure quality of service as well, right? And then the last and the most important is secret and configuration management. So what do we mean by this? Kubernetes helps us to store and manage sensitive informations, password, authentication tokens, okay, and SSH keys. So these are all part of configuration management, and this is all basically like uh, ensuring, these have to ensure security and secrecy for that matter. And we can actually deploy and update secrets and secured information and application configuration technically without rebuilding again the image containers and without exposing, okay, any of the secrets or whatever information, okay, in basically the stack configuration or something of that sort, right? So this is why actually Kubernetes is very, very good to be used, okay, for the applications which we are trying to run on the clusters which we are going to use in future, okay. So let us try to understand the components of a Kubernetes, right? So when we deploy actually Kubernetes technically, what are we doing? We will get a cluster. So we assume that we have a cluster and we want to deploy Kubernetes on it. And you know the what to say, the setup of a cluster, right? Like here, we have this node, we have node A, node B, node C, whatever, and then we have compute nodes, we have got login nodes. There are various types of nodes available, okay. And when I say I deploy in a cluster, when we deploy in a cluster, what effectively happens is we have to actually manage all these nodes. So in this diagram, you are seeing that there are 3 nodes here. Now these nodes are supposed to be clusters, okay. And then these nodes actually, if you see, are linked to the cloud through a control plane. Please understand this concept. that cloud is a service. Cloud basically is a service, right? Somebody is providing us that service, and we have an application programming interface from that service provider so that we can use this particular cluster. So what effectively happens is, you are a user at this point, you access through the cloud this particular Kubernetes cluster in such a way that you are in a position to get the facilities which are running on this node. So technically speaking, Kubernetes cluster will consist of a set of workers machines. The terminology we use is worker nodes or worker machines. That machine is going to run containerized applications, and each cluster, if you say a cluster, it should have at least one worker node. So assuming that this is my master node, okay, we will see in detail what this control plane and all these things mean, what are all these terminologies, but for the timing, assume this control plane is running on another node or a computing element which can be considered as a master node. Okay, so these worker nodes and this master node work in client server type of a mechanism, correct? So this is my master node and these are my worker nodes. So I access this through these cloud provider APIs. I submit in my job to this particular master, it distributes it to these nodes, okay, or my nodes can get the workload to be executed from these, okay, and then I give back the result. So the worker nodes technically will host the pods that are components of the application workload. The control plane, if you see this, the control plane manages actually the global decision, okay. This control plane manages the global decision about the cluster. For example, scheduling, detecting, and ensuring that the master replies to all the cluster events which are happening. So control plane components technically, okay, can be run on we assume, right, a control to be on and do not run user containers on this machine. So we call this as a provisioning node, okay, or a control node or a master node or whatever, right? So that's why when you actually log into any cluster, you have a login node, right? And login node basically does all of this, and then the compute nodes are these nodes where you actually try to execute your workload on. So let us now try to see each of these, okay, things in a bit of a brief introduction, right? You have something called as a Cube API server, right? So this is a API server type of thing, okay? So what does it do? It actually is a component which is there in the control plane, of course, that exposes the Kubernetes API, and this API server actually, okay, so assume it to be a server, you get your API from the cloud provider and you try to access it. So this is an API server for that matter, this particular master node. So this is the front end for my Kubernetes control plane. The main thing which this particular Kubernetes API server does is it can actually work with nodes, okay, for managing various pods or kubelets, okay, or something like this. So this is a point from where you can coordinate, okay, with the whole of the control plane, right? And then here we have this etcd, right, which is a persistent storage. So this is actually a persistent storage or a key value store, okay, which has got the information about whole of this cluster. Actually this has got information, and this is actually is a backing up store or a backup store, okay. So all of this data which we keep, the information about this, all of that is stored in this persistent backup storage, right? And then you have this kube scheduler, sorry, kube scheduler, okay. This scheduler here, okay, is actually going to watch for the newly created pods, okay, with no nodes assigned to them. So the basic idea is, when we were talking of slum and we were trying to tell that, okay, that is the scheduler which schedules on these nodes, here Kubernetes does that work and checks for various pods which are created, okay, and those pods are supposed to be scheduled by these schedulers, sorry, this scheduler actually, and then it selects a particular node, okay, any one of them, so that that pod runs on that particular node, right? So how does it schedule? See, I have created a pod. So pod, you can assume it to be application, right? We will discuss what is a pod, what's a Docker, what, you know already a Docker now. So Docker has a application. So that application can be considered as a pod to some extent for the time being. Please assume that to be a pod, okay. Now that particular Docker has to be run on some particular node. So you give it to, you don't know on what node you're going to run it on, okay. So that particular pod, okay, has to be scheduled. So this scheduler takes care and schedules that pod, okay, on to some particular node. Now on what basis it takes a decision, right? It takes a decision based on resource requirements. It has to check for the hardware, software, and various policy constraints. Now there can be issues of affinity. Affinity basically means that it has to actually go to that particular node itself, and anti-affinity specifications. You can take care of data locality in case of scheduling things, and inter workload interferences or something like that, right? So all of this are certain parameters which you can set when you set up your Kubernetes, and then based on that, actually the scheduling decision, right, is taken for these pods. Now then there is a control manager. There is a control manager. Now this control plane actually is a component that runs controller processes. So it has to talk of controller processes, and each controller, technically speaking, is a separate process. So you can have a controller which controls the nodes, you can have a controller which controls the job, you can have endpoint controllers, you can have service account and token controllers, you can have various type of controllers, right? So ultimately there is a control manager. So this control manager is going to either take care of your nodes. So when you say a control manager is there which takes care of my node, so you call it as a node controller. So what does a node controller do? Node controllers responsible for noticing and responding when the nodes go down. So we will see that example now today. When one of the node goes down, right? How is that node basically is shifted to some the pod which was working, or the Docker which was running on that node, okay, gets shifted to some other node automatically. This we will see in the demo today. Okay, so this is how basically a control manager works. Now then there is a cloud control manager here, right? Now this cloud control manager is a component which interfaces, right, uh, or links to your cloud provider API, and it basically is what to say, a connection, right? Or it helps you to interact uh, between the cloud platform, okay, and the various components which are there in the control plane. Not going into the details of it, but then there are certain issues which are very specific. For example, these controllers, right, when we say cloud control managers, and you are trying to link it up with, or you are trying to interface it with your cloud provider APIs, right? You need to have node controller again, you need to have root controller, and you need to have service controller. So you can actually use this technically for creating and updating, right, your cloud provider information, load balancing at that point in time, for setting up routes in underlying cloud infrastructure. All of this can be taken care by the CCM, right? And now coming down to these nodes, right? So we have this node component, okay, and these node components actually run on various nodes. So we have got a lot of node components here, right? We have got two specifically now shown, which is a kubelet and a k proxy. So now a kubelet is specifically considered to be an agent, a local agent for that node, and that runs on each of these nodes as a what to say, um, as a pod, let us say. Okay, so it's an agent that runs on each node on the cluster, and it makes sure, right, the kubelet makes sure that the containers are running in specifically a pod. Okay, now if you say from the namespaces point of view and all, I'm not going into the details, but the kubelet takes a set of pod specs, okay, provided through various mechanisms, and that particular container, right, describes in those pod specs are running correctly or not, healthy or not. So when we talk of pods being run, containers being run, we talk of in terms of health of the container, right, whether they're healthy or not, or something like that. So but kubelets generally don't manage containers which are not created by Kubernetes. This is one of the very, very important things which we should remember. Kubelets will not manage containers which were not created by Kubernetes, right? So the idea is this: if you have a Kubernetes cluster, you should make sure, right, for achieving efficiency and ensuring that Kubernetes manages all the containers, you should ensure that the containers, right, should be created using Kubernetes. Okay, and then there is something which is called as k proxy. Now this k proxy basically maintains the network rules on the nodes. So there has to be some rules, right? So these rules allow network communication between our pods, for the network sessions, okay, or communication inside or outside to our cluster. So this proxy is going to help us communicate with this control plane or indirectly to the outside world through a cloud provider or whatever. Okay, so Kubernetes of course supports runtime containers, which we'll discuss maybe in future, but this is how a broad idea of what a Kubernetes cluster actually is, right?